In this part of producers in the short run, we focus our idea on the production and the cost related to that production. So let's start sharing with you the slide, and then we will. So whenever a producer is producing, so producer is focusing on these three aspects of production very carefully. The one is total production, how much the producer is producing over a given period, like how much they are producing per day, how much they are producing per week, per month, per year. So that has to be very important information idea for a producer to keep it in mind while deciding that how much they have to produce. So that's their total production over a given period. Then comes the average product. Now, average, we need some denominator to calculate the average. Now, we have to take the denominator, which is variable. And labor is a very commonly variable factor for all the productions. So we normally calculate average product per labor. And we, in short, we can call it as an average product, but it is average product per labor. So how do we calculate it? Total product divided by the labor. So if we are producing some certain goods and we are using 5 or 10 labor, so we divide that total output with the 5 or 10 and get the average. And average is telling us what? That how much each labor is capable. On average, how much each labor is capable of producing the goods or services. Now, the third thing that the producer has to keep it in mind in the short run is marginal product. Marginal product is that if we are working with 4 labor and all our variable other factors of production or inputs, so if we add 1 more labor, so how much that labor is going to be contribute towards the total product. So total product. So in mathematically, how do we calculate? Change in total product divided by the change in labor. So that's the way we calculate. So 3 things what we discuss is total product, average product, and marginal product. And we can understand this idea with this diagram or these graphs as well as the table. So if we look at these are the number of labors we are hiring. So we start with the first labor, then second and fourth and third and fourth and fifth. So when the labor is 0, the output is 0, because without labor, output is not possible. So we see here 0 labor, 0 output. When we hire the first labor, so how much labors we are using? 1, and the total product increased from 0 to 3. And when we hire the second, now 2 workers are working, and the output is increased from 3 to 7. So by this way, when we are hiring more and more labor, we see that the total product is increasing, but up till certain point. Like here we see here that it's increasing, but we see that the change in increase is decreasing over time. And this graph of a total product, we see the relationship like that. Initially, it's increasing, but ultimately it reaches up to the point where it starts decreasing. So if we hire more labor, why is that happening? And because all other factors are constant. And this is what we're going to discuss in the next slide, law of diminishing returns. So if all other factors are constant and we are adding only labor, then the labor output increase initially, but then later on it's going to be stay same level and then starts decreasing. So how do we calculate average? So this is the total product. This is our number of workers we are hiring. So if we divide the total product, 3 divided by 1, 3, 7 divided by 2 is 3.5, 13 divided by 3 is 4.3. And we see that the average product initially starts increasing, but after the 8th worker, it starts decreasing. Like 8th worker, the average is 12.3, but after that, it starts decreasing. So if we want to plot the average production curve, so we get this curve, like it starts increasing because every the new worker is adding to the total output. But after this point, this is the point of a diminishing return or diminishing average product, and then starts decreasing. So we see it's an inverted U type graph that initially it's increase and then starts decreasing. Then the fourth column is explaining marginal product. Now, how do we get marginal product? Change in total product divided by change in labor. So we see here the change is 3 and change is 1. So 3 divided by 1 is 3. Here the change is 4 because 7 from 3 to 7 it's at 4, and the change in labor is 1. So we see marginal product is 4, and so on. If we see, so the marginal product increase up to 25, then starts decreasing. So 25 means like between 6 and 7 labor. So it peaks here in the graph. Again, this is very similar like the other one, in inverted U type. It's go increasing, and then reach up to the maximum point and then starts sharply decreasing. So these are the three things from the production. From this analysis, we can drive this law, which is called law of diminishing returns. As the name is reflecting, it's a diminishing returns. So the output is returns. Like for input, the outputs are the returns. So output is decreasing with the diminishing. It's as we are hiring more and more fixed factor, the variable factor, and the fixed factors are fixed. In that case, the returns are decreasing, and this is what we call it as a law of diminishing returns. We observe this law of diminishing return in our daily life very quite often. Has such successive unit of variable factors has less and less fixed factor to work with. So eventually, a equal increase in work effect begins to add less and less to the total output. So we also noticed here the relationship between marginal product and average product, and also observed through the graph that when an additional worker output raises average product, marginal product exceeds average product. So if the marginal product is higher than the average product is increasing, and vice versa. Like if the additional worker output reduce average product, MP is less than marginal product. So below. So if you look at this graph again, up till this point, the marginal product is higher than average product. So average product is increasing. But after this point, when the average product is at its maximum, the marginal product is below the average product, starts less than average product. So average product also starts decreasing. So this is the AP curve slopes upward when the marginal curve is above it, and the AP curve slopes downward, the marginal curve is below it. So I showed you there on the graph. So it follows that the marginal product curves intersect the average product at its maximum point, and I also showed that this is the maximum point for average product, and it here the marginal product and average product are equal. So we can say that if we want to see what is the point where the marginal product is maximum, is the point where average product is maximum, where the point the marginal product is equal to average product. So this is the point we can say. Now these are the three very common examples of a law of diminishing law of diminishing returns. Like if we go for a fishing, the number of fish per person fishing has decreased, and average hours fished for each fish caught has increased. So if we do too much fishing, so what is going to happen? The fish stock will go down. So now it takes more time to get a fish. Or pollution control, like if we put more and more filters to reduce filters lead to diminishing returns, because the first filter is extracting a lot of impurities, but the second, third, and it's not going to be portfolio diversification means that if we are adding more and more different stocks in your portfolio in order to reduce the in order to diversify the risk, a point will come that each additional stock is not going to reduce the portfolio, decreasing rate. So that's what we can see. Now we focus. Now we are shifting our focus from the output to the cost related to the output. Now the costs are of again with the very clear in mind. There are certain costs which are fixed, which cannot be changed, whether we are producing 0 units or 100 units or 1,000 units. So it is not based on number of units what we are producing over a specified range of output. but after that it's going to be increased as well. So fixed cost over a specified range, it is fixed. Then there is a variable cost. Variable cost means that the cost is increasing. For example, like if you want to produce cookies, so flour, chocolate chips, and sugar, these are all the costs which are variable. Like if you want to produce more cookies, you want to buy more flour and more chocolate chips and more these ingredients. But if you rented a place or a bakery to bake all these things, so in that case, what is going to happen? The rent is going to be fixed. So rent is a fixed cost, whether you produce zero output or 100 cookies or 200 cookies. So that's the way it's worked. So total cost is a combination or the sum of the fixed cost and the variable cost. Now we can take the averages of these as well, like average total cost, average fixed cost, average variable cost. But again, the relationship is going to stay at the same level, same point, like average total cost is equal to average variable cost plus average fixed cost. Then it also comes the marginal cost idea, that what is the cost if we produce one more unit? Because we normally, when we are producing output, we decide the things that how much we have to produce based on our marginal cost. So marginal cost is an increase in total cost resulting from producing one more unit. And how do we calculate change in total cost divided by change in output, like how much we're producing? So by this way, we can get the value for marginal cost. So marginal costs are always marginal variable cost, because fixed costs do not change with an output varies. These are the shapes of the curves. Like you can see that the total cost curve is like this, and the total variable cost curve is like this, and there's a total fixed cost. So we very carefully look at these graphs. So we see that the variable cost is starting from 0. Why? Because if we are producing 0, so variable cost is 0. If we are producing 10, the variable cost is going to increase, or 120, the variable cost is going to increase. So we see that this is a variable cost. The total cost curve is very symmetrical with the total variable cost, but it is at a higher level. Why? Because this difference is the fixed cost. So total fixed cost. And you see here, the fixed cost curve is straight line, horizontal line, right? Now, when we look at the averages, so averages give a very special value. So if you look at this average fixed cost first, so we see the curve is starting from a very high point, and it's always decreasing over a certain range. So we see here that it's decreasing. Average variable cost, it's a U shape. Initially, it's decreasing, and then it's also decreasing, but after a certain point it starts increasing because of the inefficiency, or again the same law of diminishing margin, diminishing returns is going to apply. And marginal cost is also a U-shaped cost, like it's going to be reached. And average total cost is also some sort of a U-shape. You see here that it starts rising. Average variable cost. What is understandable, the difference between the average variable cost and average total cost is the fixed cost. And that's why we see that these two curves started with a very huge difference, but gradually over a production, as the production is increasing, and they are converging, or they are getting closer to each other. So the ATC curve, average total cost curve, is derived geometrically by vertically adding average fixed cost and average variable cost. So that's a ATC curve declines initially as output increases, reach a minimum, and then rises again. Output increases further. So ATC curve is a U-shaped curve. You see here, these curves are U-shaped curves. Now, key idea with the U-shaped curve is that each additional worker adds the same amount to total cost, because the worker wages are fixed. So when we hire the new one more worker, the cost is going to be added up, which is equal, but a different amount to output because of the law of diminishing returns. So eventually, AP of the variable factor implies an eventual rising of average variable cost. So every variable cost is its minimum when average product reach its maximum. Eventually, diminishing marginal product of the variable factor implies a rising marginal cost. So marginal cost reaches its minimum when the marginal product reaches its maximum. So it's a inverse relationship like when we are producing more. So definitely the point at which the marginal cost is marginal product is maximum. So definitely the average marginal cost is minimum. Now there's an issue of a capacity. Why? Because we discussed so far is that other factors are fixed and one factor is variable. So the level of output that correspond to the minimum short-run average total cost is the capacity of the firm. So capacity is the largest output that can be produced without encountering a rising average cost per unit. So a firm that is producing an output less than the point of a minimum average total cost is said to have an excess capacity, because they are producing a point which is not at a minimum average total cost. So these curves can shift as well. An increase in the price of a variable cost shift the average total cost and marginal cost upward, because that's only affecting the variable. An increase in the price of fixed factor increase the firm's average total fixed cost, but its variable costs are unchanged. So ATC curve shifts up, but marginal cost does not, because marginal cost is affected with the variable cost. So we see here that the marginal cost is shifting and ATC is shifting in the short run. So we see an increase in variable cost shift the ATC and marginal cost curve. An increase in the price of a fixed cost factor increase the firm's total fixed cost, but its variable costs are unchanged. The ATC curve shifts upward, but MCK does not. So here we see MC is only shifting because of a change in or increase in variable cost. And we see here the ATC is shifting because of both the factors. It can be because of a variable cost or as well as because of the fixed cost. Now with our example which we face nowadays is the digital world. A digital world when diminishing returns is not disappearing altogether, is not working well. The reason is that the initial cost, like for example, in order to understand what is digital world, like development of a software or an app or writing a novel or something like this, or making a movie or something. So we see what is happening with that. We need an initial cost to produce that, to develop that, to make that, right? But after that, if you sell to more people, or if we want to produce more copies of the software or the movie or a app, the cost is almost reached to zero. So in that case, you see that the average total cost curve is not U-shaped, it's always decreasing. So many digital products have a large initial cost. The initial cost is very large, near zero marginal cost. So law of diminishing marginal returns does not apply. Law of diminishing marginal returns does not apply. The law, what we discussed, it's a law, sorry, it's a typo. So marginal cost curve is the same low value for all units. So in this case, average variable cost is a marginal cost, and ATC declines because of this spreading fixed cost. So in that type of industry or products in which we are making the digital things, like the copy of that is without any cost. So if the initial fixed cost is very large, but variable cost is very nominal, very negligible. So we see here it's a very different, and the law of diminishing returns is not going to be work. So this is all what I want to discuss with you from producers in the short run. Next, we're going to discuss in our coming videos producers in the long run. And we see the same perspective, the same issues, but with a long-term perspective. So hope you like it, and please have a comments down or subscribe my channel.